All right, this is number 5, final review, graphing quadratic equations. So the overview of quadratic equations is this. You can either graph or solve them, or you can do both. And when you graph, there are 3 different choices. Standard form is actually broken into 2 in your notes, with B, which are very simple, with B, which are not as simple, and then without B, which are quite simple, meaning B is 0. The other form is vertex form. The nice thing about vertex form is it gives you your axis of symmetry, and it gives you your vertex ordered pair very simply if it's in that form. And then you just have to find 2 other points and reflect them. And then the intercept form is very nice in that it gives you quite simply gives you the vertex actually, which also would then give you the axis of symmetry. But it gives you the 2 points that are your x-intercepts, and you only have to calculate 1 point and reflect that. So all of them have benefits, and we're going to look at all 3 in this particular recording in number 5, final review. The other thing you can do with quadratic equations is to solve them, and we'll look at this in number 6, final review. You can solve by, and the 2 we're looking at are factoring and using the quadratic formula. Factoring sometimes works, but it is a necessity for you to know that because you will be asked to factor at times. That's where you use either the guess and check, or you have been taught to use the AC method when guess and check doesn't work very well. Okay, the nice thing about the quadratic formula is it always works. You can solve any quadratic equation, any of them, using the quadratic formula. There are other ways of solving, completing the square, solving for the x value if the b is 0, but for right now, we're going to focus on these ways of doing it. You are going to graph a quadratic equation in one of each of these forms. The first one will be standard form, then vertex form, then intercept form. So your first problem is y equals x squared plus 2x minus 3. I've given you a format and a graph. You'll have to use your green graph paper. Go ahead and solve this and then turn the video back on and see how you did. Okay, the a, b, and c for y equals x squared plus 2x minus 3 is a is 1, b is 2, and c is negative 3. We know because the a is 1, it's going to open up. The axis of symmetry is given by the formula x equals negative b over 2a. I, however, prefer the x equals negative 1 times b over 2a, just in case your b is negative. When your b is negative, you can make signing errors. So I have x equals negative 1 times 2 over 2 times 1. 2 over 2 times 1 is 2 over 2 times negative 1. 2 divided by 2 is 1 times negative 1 is negative 1. So the x equals negative 1, vertical axis of symmetry line, crosses the x-axis at negative 1. We have to find the y-coordinate, so we plug it into this formula, x squared plus 2x minus 3. So y equals negative 1 squared plus 2 times negative 1 minus 3, just plugging in the x value into the quadratic equation to get your y value. So negative 1 squared is what? Y equals 1 plus 2 times negative 1 is negative 2 plus negative 3. Negative 2 and negative 3 is negative 5 plus 1 more is negative 4. So the ordered pair for the vertex is negative 1, negative 4, which is plotted and labeled here. Now, I'm looking at the graph, and I can see that I can use 0, so I'm going to. So if I plug in 0, then these 2 terms, the x squared and the 2 times x, with the 0 product property, they'll go away, and you're going to be left with negative 3. So you have 0, negative 3. We plot it. It's 1 to the right of the axis of symmetry, go 1 to the left, and reflect it, and you get negative 2, negative 3. You're up to 3 points now. I can also see that 1 can easily be substituted, so I substitute in 1 for the x, so y equals 1 squared plus 2 times 1 plus negative 3. 1 squared is 1, 2 times 1 is 2, and then negative 3. 2 plus 1 is 3, plus negative 3 is 0, so 1, 0 is the ordered pair. You can see that it is 2 to the right of the axis of symmetry, go 2 to the left, and you get negative 3, 0. We now have 5 ordered pairs, and we have correctly plotted our parabola. Okay, now we're going to the next method. which is graphing a quadratic equation in vertex. Okay, in vertex form, the quadratic equation looks like y equals a times, and that a is the leading coefficient, in parentheses x minus h squared plus k. The pattern that's important for you to remember is this minus h plus k. So the a value in this problem right here, you need to look at that, follow that pattern, complete all your work, graph this. As soon as you feel like you've got it done correctly, or if you get stuck, you turn it back on and listen to the recording. All right, even though a wasn't given here, it's there. It's actually 1, which means the parabola will open up. We've got the pattern minus h plus k, minus 4 plus 2. It's following the pattern, which means that h is going to be 4 and k is going to be 2. So the axis of symmetry is given as x equals h, so x equals 4. Then we draw a vertical line that crosses the x-axis at 4. The vertex's x-coordinate will be exactly the same as the axis of symmetry, so it'll be 4, it'll be h. K is 2, so 4, 2. We plot 4, 2, label it. Now we need 2 additional points with the table, and then we're going to have the 2 reflected points to get our total of 5 points. I can look at the axis of symmetry and see I can choose 3. I might be able to choose 0, but I'm thinking I'll go off the graph. So I'm just going to go in 1 to the left of 4, which gives me 3, substituting it in, gives me 3, 3. I plot it, reflect it, I get 5, 3. Then I'm going to go 2 from the axis of symmetry, which I did here on the left. So I plug in 2, y equals 2 minus 4 squared plus 2. I'm just plugging right into the formula here. And 2 minus 4 is negative 2, so y equals negative 2 squared plus 2. And then y equals negative 2 squared is 4 plus 2, which is 6. So 2, 6. That's 2 from the axis of symmetry on the left. I go 2 from the axis of symmetry on the right, and I get 6, 6. Now I have 5 points. My parabola is properly opening up, and so I should be correct. And the last one we're going on to is the intercept form. So make sure you have 3 problems written, work shown for all 3, and all 3 graphed. So just in case you're not keeping up with that, let's just make sure of that. All right, next page. Okay, so we're graphing the quadratic equation in intercept form. Highlighted as intercept form, y equals a times a leading coefficient times x minus p times x minus q. These are going to be your intercepts. Okay, there you're seeing factored form here. So intercepts will be p comma 0, q comma 0. You can just graph them right there. Now, I would do that first, even though it's the 3rd step, because the axis of symmetry is just finding the middle point, drawing a vertical line, and then finding your vertex is going to be the same x-coordinate as the axis of symmetry. All you have to do is find the y by plugging into this formula here. Then you're left with just simply finding one ordered pair and reflecting it. I'm going to be talking to you a little about the intercepts in terms of the zero product property. You don't really need it, but I will be talking to you about it when we get there. Okay, go ahead and try and solve it. As soon as you think you're finished, go ahead and turn it on again and check your work. Okay, you probably had a little trouble on this one because it had such a large vertex as y-coordinate. But let's go ahead and start with the intercepts first. Hopefully you did that. So the intercepts would be p comma 0, and we know that p is 3, so 3 comma 0, and q, which would be negative 5, 0. So if you looked at this, it would be from 5 to 0 is 5, from 0 to 3 is 8. So if you'd gone 4 on either side, 1, 2, 3, 4, 1, 2, 3, 4, your axis of symmetry would have been at negative 1, so x equals negative 1. Now here's how you actually get this mathematically. You take the p and the q, you're finding a midpoint. So 3 plus negative 5 divided by 2. 3 plus negative 5 is negative 2 divided by 2, which is negative 1. Same answer. So our vertex amount comes, our x-coordinate for our vertex comes from that x value, negative 1. Now our y value ended up being really huge, so I apologize for that. So negative 1 minus 3 times negative 1 plus 5. We're just plugging it into this formula, this equation here. Negative 1 plus negative 3 is negative 1 plus 5 is 4. Negative 1 plus negative 3 is negative 4. Negative 4 and 4 is negative 16. I just made 6 lines down below 10 and went one to the left and put negative 116. It's not great, but it's what we had to do on this one. Now, we're going to go ahead and look at the intercepts. We know they're 3, 0, and we know they're negative 5, 0. But I want to show you how to use the zero product property, because this is what you have to do when you're solving a quadratic equation using factoring. So the zero product property says that if your y value is 0, it's going to be an x-intercept. So negative 5, 0, 3, 0. We can see that. So in order to use that zero product property, it says if x minus 3 were 0, then you multiply it by whatever x plus 5 is, you'd still get 0. If x plus 5 were 0 and you multiply it by whatever x minus 3 is, you're going to get 0. So zero product property. Product means multiplication. So you say to yourself, x minus 3, what would x be to equal 0? So x minus 3 equals 0. Add 3 to both sides, x equals 3. Exactly what we came up with here. Then you say to yourself, what plus 5 would give us 0? Well, it's negative 5, but if you don't know that, if it's not that simple, you would say, okay, x plus 5 equals 0. Subtract 5 from each side, you end up with x equals negative 5, which is exactly what we came up with here. Now, we're going to need 2 other values. Now, I don't want to pick 0, because I know 0 is going to be really far down here. So I went ahead and picked something close to 3. So I could have picked 2. I guess I could have picked 4, but I thought 2 was a safer bet. So when I plugged in 2, I got y equals 2 minus 3 times 2 plus 5, which is substituted the 2 into both x positions. 2 minus 3 is negative 1, 2 plus 5 is 7. Y equals negative 1 times 7, which is negative 7, so the ordered pair is 2, negative 7. Plotted here, it is 1, 2, 3 to the right of the axis of symmetry. Go 1, 2, 3 to the left. You get negative 4, negative 7. Connect your points and you are finished. Okay, this is how we've synthesized, put together all 3 of the ways in which one can graph a quadratic equation. There are videos or recordings for each of the 3 separate ways if you're having trouble, so you could go back and look at those if this is not making sense to you.